Today in this session we are discussing some problems based on maximum power transfer theorem. In previous session we discussed about maximum power transfer theorem and we proved many different cases. There are mainly three different cases. One is DC source with the internal resistance is connected to variable load resistance, that is the case number 1. Case number 2, AC source with internal impedance is connected to once again variable resistance, and case 3, AC source with internal impedance is connected across variable load impedance. In that there are two different cases, only RL is variable and only XL is variable. Now that's all the problems based on these three cases. First see the question, find the value of RL. Find the value of RL such that for what? For P max. P max andre find the value of RL in which we can transfer a maximum power from source to load. Okay. Then after finding the value of RL to transfer a maximum power from source to load, then what is that maximum power again, and also find that maximum power. So in simple way, I can say just find out RL, the value of RL such that we can transfer a maximum power from source to load. That is the first case. After that, then find out what is the amount of power transferring from source to the load. Is that clear? Say, we already discussed Thevenin's theorem, Norton's theorem. While solving any problem by using maximum power transfer theorem, first we need to obtain Thevenin's equivalent circuit. I mean, once again we are following Thevenin's theorem in order to obtain Thevenin's equivalent circuit, because that Thevenin's equivalent circuit consists one source with a internal resistance or impedance, finally that is connected to load. So by knowing the type of source and type of load, yes, we can decide what is the type of source and what is the type of load, whether it is comes under case 1 or case 2 or case 3. See, in case 1, DC source is connected to a variable load resistance, RL is equal to R0. In case 2, AC source is connected across variable load resistance RL, RL is equal to magnitude of Z0. Last case, when AC source is connected across a variable load impedance, ZL is equal to complex conjugate of Z0. So only by knowing the type of source and type of load only we can determine what is in which particular condition we can transfer a maximum power from source to load. By seeing this circuit clearly, it indicates this comes under case 1 because this is DC circuit. So that single voltage source is DC. Yes, obviously that internal resistance, then that is connected to variable load resistance, unknown resistance. That is what we are going to find out RL to transfer a maximum power from source to the load. Is it clear? So the first thing we need to find out the Thevenin's voltage. Next step, Thevenin's resistance. Then write Thevenin's equivalent circuit. Then we can understand what is the type of source and what is the type of load. Then we can analyze if it comes under case 1 or case 2 or case 3 based on which case or what is the type of source and type of load. Yes, we can write the condition. Is it clear? Now, what is the first step to find out the Thevenin's voltage? I mean V0. First step is remove the load. Yes, let me remove the load first. Okay, then the voltage across this open circuit, I mean across the load terminal, is denoted by V0. That V0 is known as Thevenin's voltage. Anyhow, by using any method we can find out V0. So for this circuit, I would like to consider nodal analysis, because how many nodes are there in this circuit? Say here please don't get confused. This is not, these two are not separate nodes. See, let me modify this circuit. Just I am altering the circuit. See, how many nodes are there in the circuit? Only one node in the circuit. Is it clear? So, and let me call it as V1, or because of a single node we can denote it by V also. Next, apply KCL for node V1. Apply KCL for node V1. All these concepts we already discussed in module 1. How to apply KCL, KVL, super node analysis, super mesh analysis and all those things. How to apply KCL for this node? In this branch, what is the current? V1. According to this polarity, it supplies the current upward, right? Therefore, V1 minus 5, V1 minus 5 divided by what is the resistance value? 8. Plus, what is the current in this branch? V1, another end is connected to ground, right? So, what is the potential difference across 4 ohm resistor? V1 minus 0, that is the potential difference. Then what is the current? V1 by 4. V1 by 4. Next, 2 ampere current is entering into node. Already, so many times we discussed, when you are applying KCL for any node, just assume all the branch currents are leaving from the node. Therefore, this 2 ampere current is entering into node. So, that's why minus 2 ampere. Is it clear? Next, what is the current in this branch? 0. Though there is a 2 volt voltage source and resistance, this is a open circuit. This terminal is open terminal. There is no closed path for a continuous flow of current. Okay, that's why the current does not flow through any open circuit. Therefore, what is the current in this branch? 0. Okay, because only 4 branches are connected to this node. Out of 4 branch, 1 branch is an open terminal. So, the current in that terminal is 0. So, that is equal to 0. Algebraic sum of current at any node point is equal to 0. Next, simplify this equation. Yes, V1 by 8 minus 5 by 8 plus V1 by 4 minus 2, that is equal to 0. Next step, take a V1 as a common factor. 1 by 8 plus 1 by 4 is equal to minus 2 shift to RHS, 2 again minus becomes plus 5 by 8. Is that clear? After simplifying this equation, you will get V1 is equal to 7 volts. V1 is equal to 7 volts. So, the voltage at this node point is 7 volts. Therefore, the voltage across 4 ohm resistor is 7 volts. Because what is voltage across 4 ohm resistor? V1 minus 0. Therefore, V1 is equal to 7 volts. Again, what is voltage across this 2 ampere current source? Once again 7 volts, because these two are connected in parallel, right? But the voltage across this 2 ampere current source is not exactly same as voltage across this open circuit terminal, because of this voltage source. Is it clear? 2 volt voltage source is absent in the circuit. Then we can consider the voltage across 2 ampere current source is exactly same across voltage across this load terminal. Because of this 2 volt voltage source, yes, we need to consider this 2 volt voltage source also. That's why, yes, just apply KVL. Let me consider the voltage across 2 ampere current source. How much? How much? 7 volts, right? 7 volts with a polarity, because we always consider current flows from higher potential to lower potential. That's why I denoted current is flowing from V1 to ground. That's why plus to minus. Okay. Now apply KVL for this loop. Yes, minus 7 volts X, what is voltage across this resistor? 0. Though there is a voltage source here, this is a open circuit. Current does not flow through this resistor, means there is no question of voltage drop. There is no question of voltage drop. Therefore, the voltage across this resistor is 0. So next, again according to clockwise direction, plus 2 volts, plus 2 volts. Next, what is voltage across this open circuit terminal? Plus V naught, that is equal to 0. Is it clear? I am explaining why I am considering V naught is equal to 7 minus 2. If polarity is minus to plus, 7 plus 2. So don't get confused. Just consider this slope, apply KVL. The voltage across 2 ampere current source is 7 volts. The voltage at this point is 2 volts. What we are going to find out? Voltage across load terminal, right? Just assume that the voltage across the load terminal is V naught with this polarity plus to minus. Therefore, V naught is equal to 7 minus 2. So, V naught is equal to 5 volts. V naught is equal to 5 volts. That V naught is nothing but Thevenin's voltage. V naught is equal to V1 minus 2. So, 7 minus 2, V naught is equal to 5 volts. That voltage is nothing but Thevenin's voltage. What is the next step to find out the Thevenin's equivalent circuit after finding V naught? To find R naught, right? So, to find R naught, next to find R naught, yes, please remember the statement of the Thevenin's theorem. To find out R naught, view from the load terminal, just view from the load terminal into the circuit, view from the load terminal, view from the load terminal into the circuit by replacing all voltage source by replacing all voltage sources by short circuit. One more voltage source here, all voltage sources by short circuit and current sources by open circuit. Open circuit means just remove this current source. Is it clear? This is how we can find out R naught. R naught is nothing but Thevenin's resistance. Now, yes, that is to find out R naught, right? Now, 8 ohm and 4 ohm resistance are connected in parallel. This parallel combination is then connected in series with 4 by 3 ohms. Is that clear? How we can write in this equation form? R naught is equal to, yes, 8 into 4 divided by 8 plus 4. This parallel combination then connected in series with 4 by 3, right? So, plus 4 by 3. Is that clear? Because by replacing all voltage sources by short circuit and current source by open circuit, then view from the load terminal into the circuit by replacing voltage sources by short circuit and current sources by open circuit, then find out effective resistance of the circuit. Is that clear? So, you will get 8 into 4 divided by 8 plus 4 because those two resistances are connected in parallel. Then this combination is then connected in series with 4 by 3. By simplifying this, you will get R naught is equal to 4 ohm. R naught is equal to 4 ohm. Next, by knowing V naught and R naught, yes, we can write Thevenin's equivalent circuit, right? So, what is the Thevenin's equivalent circuit consist? Minus to plus V naught, right? How much? V naught is equal to 5 volts. Next, then connected in series with R naught. R naught is equal to 4 ohms. That combination, I mean this Thevenin's equivalent circuit is connected across variable resistance. Now, clearly you can understand what is the type of source and what is the type of load. What is the type of source? DC source with internal resistance R naught, then that is connected across variable load resistance. So this circuit comes under case 1. Okay, in case 1, in which particular condition we can transfer a maximum power from source to load? When RL is equal to R naught. Is that clear? What is RL? That is equal to R naught. What is R naught? Already we calculated, that is 4 ohm. That is the first part of the question. Say, find the value of RL for P max. Means find the value of RL for which what we can transfer a maximum power from source to load. After finding that condition, then find out what is maximum power. So what is the formula to find out the maximum power? P max is equal to yes, what is the power transferred to this load? What is the current through this load? IL square into RL. The formula to find out the power is I square into R. We are calculating what is the amount of power transferred to the load, right? That's why. What is the current through load? IL square into RL. Okay. Next, what is IL? What is current through load? It is a single loop circuit. Easily we can calculate what is current through load. IL is equal to, yes, V naught divided by R naught plus RL. V naught divided by R naught plus RL. But R naught and RL are equal because this is the condition in which we can transfer a maximum power, right? Therefore, V naught by 2 R naught. So what is V naught? 5. 2 into R naught means 8. So 2 into 4. So what is this? What is this? 5 by 8. Just substitute this in place of IL. So P max is equal to 5 by 8 whole square into what is RL? RL is equal to 4. By simplifying this equation, you will get 1.56 watts. Is that clear? Say, if any question, find the maximum power or what is the condition to transfer a maximum power for any given problem. First, you need to calculate, you need to obtain Thevenin's equivalent circuit. Then only you can come to know what is the type of source and what is the type of load. Next, by knowing the type of source and type of load, yes, we can consider whether it comes under case 1, case 2 or case 3. According to which case we can substitute the condition and we can find out the value of RL and also we can find out maximum power. Thank you. Okay, now let us solve one more problem. It's another type of problem because the previous problem is DC circuit. The type of source is DC source and type of load is variable resistive load. This problem, see the question, find ZL. ZL means the type of load is impedance, variable impedance for P max. In which particular condition we can transfer a maximum power. So what is that corresponding variable impedance value? After that, and also find P max. Here say across AB, that is given across AB. I mean the load is connected across the terminal A and B. The load is connected across the terminal A and B. So once again, first we need to obtain Thevenin's equivalent circuit. So in order to obtain Thevenin's equivalent circuit, first to find V naught, So the voltage across these terminal A and B is nothing but V naught because the load is already removed. What is that load? ZL, variable impedance. Once again, I would like to suggest, once again apply Kirchhoff current law only, nodal analysis only. Let us consider this is a node, okay, and let me call it as V1. Is that clear? Apply KCL for node V1. Apply KCL for node V1. Say there is no polarity for a source because it is a AC polarity. Still you can take a reference polarity because you can take any polarity because every off cycle the direction of source, the polarity of source will get reverse. Okay, I will consider minus to plus only. You can take any polarity, not a problem. Yes, first what is the current in this branch? V1 minus 10 at an angle 0 divided by what is this 5 at an angle 60, that is impedance. Because it is a AC circuit, impedance means it is a combination, whether it is a combination of RLC or RL or RC or LC, whatever. Okay, that's why we can see a angle, that is the phase difference between voltage and current. Is that clear? Now, so V1 minus 10 at an angle 0 divided by impedance, just like a resistance. By Ohm's law, what is I? V divided by R. What is V? V is nothing but potential difference. What is the potential difference across this branch? V1 minus 10 at an angle 0 minus 0. I am not going to write this minus 0. Directly I will write V1 minus 10 at an angle 0 divided by R, right? Instead of resistance, because of what is the type of circuit? AC circuit, I have to write impedance Z. What is that? 5 at an angle 60. 5 at an angle 60. Okay. Now what is the current in this branch? 0, because the load is already removed, right? When the load is removed, this path becomes open circuit. What is the current in this path? 0. So next, what is the current in this branch? V1 minus 5 at an angle 90. So plus, I am not going to write this 0. Okay. So V1 minus 5 at an angle 90 divided by, what is the impedance value? 10 at an angle minus 30, that is equal to 0. First let us find V1. Later we can discuss how to obtain V0. Okay, just simplify this equation. V1, let me take V1 as a common factor directly. V1, so 1 divided by 5 at an angle 60. V1 common factor 1 divided by 5 at an angle 60 plus again V1 common factor 1 divided by 10 at an angle minus 30. Then what is remaining? Minus 10 at an angle 0 divided by 5 at an angle 60. Again after this minus 5 at an angle 90 divided by 10 at an angle minus 30, that is equal to 0. Is that clear? Next, by taking V1 as a common factor, simplify this term first. First, keep your calculator in complex mode. Then use proper brackets. First open the bracket. Once again open the bracket. Enter 1 divided by 5. You can see option to enter the angle. I am already explained how to enter these values by keeping your calculator in complex mode. Enter this value, close the bracket, plus again open the bracket, 1 divided by 10 at an angle minus 30, close the bracket, again finally once again close the bracket. Okay, then press the equals. First always you will get the answer in rectangular form, but I suggested keep your answer always in polar form. You know how to obtain answer in polar form. Just get the answer in polar form. Again simplify in same way, simplify this thing also, the second part also. Finally, because at a time we can simplify, if you miss one bracket, one set of brackets, the complete answer will be wrong. So instead of that, you calculate separately. Okay, after that again during division, once again enter in the same complex mode only, calculate the answer in order to avoid the mistakes. So by simplifying this equation, you will get V1 is equal to 6.81. You know how to enter all these values in your calculator by keeping it in complex mode. You practiced, right? Just enter 2 or 3 times, you just try to obtain this answer. Be careful, use extra set of brackets. Okay, when if you are not know, when you are you don't know how to use the brackets, it's very difficult to get the accurate answer. Okay, so 6.81 at an angle minus 27.18 volts. Try to get this answer. Okay, this is V1. But what we are going to find out, V0, right? See, what is V0? Voltage across the terminal A and B, right? Correct? So, VAB is nothing but V0. VAB is nothing but V0. VAB can be written as VA minus VB. Correct? See, VA is directly connected to V1, right? Therefore, in place of VA, we can write V1. Because VA and V1 are directly connected. You can shift this point to this point, right? Therefore, VA is nothing but V1. Next, minus, what is VB? VB is directly connected to, what is this? Ground. Then, what is VB? 0. Therefore, V0 is nothing but V1. V0 is nothing but V1. How much? 6.81 at an angle minus 27.18 volts. This is nothing but Thevenin's voltage. Is it clear? Next, after finding V0, next need to calculate Z0, right? So, how to calculate Z0? Yes, view from the load terminal. Where is the load here? These two terminals are the load terminals, right? By replacing all voltage source by short circuit. There are two voltage sources in the circuit. Replace those two voltage sources by short circuit and current sources by open circuit. There is no current source in the circuit. Then find a impedance, effective impedance across the load terminal. You just shift these two terminal. Just shift these two terminal. This is VA, right? And let me call it as VB. Just find the effective resistance between these two terminal. Just shift this impedance to this point and this impedance to this point. This looks like a parallel combination. So Z0 is nothing but, say, Z0 is nothing but the parallel combination of 5 at an angle 60, that impedance parallel with 10 at an angle minus 30. Okay, just find out again, please keep your calculator in complex mode and calculate this parallel combination effective value. What is the formula? Z is equal to 5 at an angle 60 into 10 at an angle minus 30 divided by 5 at an angle 60 plus 10 at an angle minus 30. Okay, and write the answer in, first you can write the answer in polar form only, but in case 3, what is the condition? ZL, variable impedance, is equal to complex conjugate of Z0. I mean, if x plus iy complex conjugate, x plus iy complex conjugate, what is that x plus iy complex conjugate? X minus iy, right? Correct. So therefore, x plus iy means which form? Rectangular form. That's why only in this case, try to express Z0 in rectangular form. Anyhow, first I will write what is Z0 value in polar form. Again, you have a option to take answer in rectangular, right? Shift 2. Then you will get 4 options, right? Out of that 4 options, one is the theta r at an angle theta. Another one is a plus bi. A plus bi form is nothing but rectangular form. Please try to convert back polar form into rectangular form. So first, let me write Z0 value is 4.47 at an angle 33.43. Z0 value in the polar form. But in a case 3, try to express Z0 in rectangular form only. So, Z0 is equal to 3.73 plus J 2.4x. Rectangular form means x plus iy form. Polar form means magnitude at an angle theta. 4.47 magnitude at an angle. Rectangular form means x plus iy form. I will explain why I am suggesting try to keep Z0 in rectangular form. Is that clear? So, by knowing V0 and Z0, just write Thevenin's equivalent circuit. What is the Thevenin's equivalent circuit consist? Yes, this is V0. How much? V0 is equal to 6.81 at an angle minus 27.1. Next, Z0. Z0 is equal to same value here only. Correct? Then that is connected to, these two are the terminal A and B, right? These two are the terminal A and B. That is the load terminals, right? Connect variable load impedance. Okay. Now you just tell me what is the type of circuit? AC source. AC source with internal impedance Z0 is connected across variable load impedance. In this condition, what is the condition to transfer a maximum power from source to load? ZL is equal to complex conjugate of Z0. We already proved this condition, right? ZL is equal to complex conjugate of Z0. What is complex conjugate of x plus iy? X minus iy. What is complex conjugate of 3.73 plus j 2.46? 3.73 minus this imaginary coefficient, that sign becomes minus j 2.46. This is the value of ZL for what? In order to transfer a maximum power from source to load, what is the condition? ZL is equal to complex conjugate of Z0. Then what is Z0? 3.73 plus j 2.46. Then what is complex conjugate of Z0? 3.73 minus j 2.46. I hope now all of you understood why I suggested to write Z0 in rectangular form. It is not possible to write this polar form of this complex form. I mean complex conjugate of this polar form. That's why I suggested to express Z0 in rectangular form only. After finding ZL, so what is the next question? Find P max, right? Yes. What is the formula to find out the P max? P max is equal to IL square into RL. Once again I am mentioning, I am not writing ZL because ZL consists resistive part and reactive part. Out of these two parts, the one and only element which consumes the maximum power, that is resistance. The power consumed by the pure inductor, 0. The power consumed by pure capacitor, 0. That's why I am considering only the variable load resistance. Is it clear? So, in order to find out P max, first let us find out IL, right? IL is equal to yes, V0 divided by Z0 plus ZL. Z0 plus ZL. You know what is Z0? 3.73 plus j 2.4x. What is ZL? 3.73 minus. So this plus and minus will get cancelled. Then what is remaining? IL is equal to, anyhow, V0 value you know how much? 6.81 at an angle minus 27. Therefore, 2 times of 3.73. 2 times of 3.73. So, by simplifying this, you will get IL is equal to 0.912 at an angle minus 27.18 amps. Okay. So, you know what is V0, right? 6.81 at an angle minus 27.18. divided by Z naught 3.73 plus J 2.46 plus what is ZL 3.73, because plus 3.73 plus 3.73 you can write 2 times of 3.73 plus J 2.46 minus J 2.46 will get cancelled. That is why I am written 2 into 3.73. So you will get this answer 0.912 at an angle minus 27.18. After that, just find out by substituting in this equation, P max is equal to IL square, you know what is IL square, into what is RL? What is RL? See, this is ZL, right? Out of this ZL, what is RL? This is the RL. This is the RL. This is the resistive part. And what is this? Reactive part. Then what is RL? 3.73. 3.73. So by simplifying this equation, you will get P max is equal to 3.10 watts. Is that clear? So we covered 2 problems. The one is the case 1. Second one is the case 3. What is case 2? Instead of this impedance, you will get variable resistance, that is RL. Then what is the condition to transfer a maximum power? RL is equal to magnitude of this Z naught. How you can find out the magnitude? So give x plus iy is the complex number. How we can find out the magnitude? Square root of x square plus y square. Same way, square root of 3.73 square plus 2.46, or else in polar form directly the magnitude is given. In polar form directly the magnitude is given. How much? 4.47. Therefore RL is equal to 4.47. That's all. If the load is variable impedance, this is how we can find out what is the condition. ZL is equal to complex conjugate of Z naught. Then find out IL, then find out P max. Thank you.